Test, test. Test, test. Well, hello, hello. I spy a Pyrex. Haha! At it! I've hopefully got most of this working. Indeed, we are gonna play with science. And also a happy new year to you as well. I had to put it in the title, it only felt appropriate. 5x5? Oh? Does this science come with some multiplication? I mean, yes, that does equate to 25. I see what you did there. And I can't help but feel the SpongeBob joke. You know what's funnier than 24? 25. Hopefully, we can hope, right? I hope, please, yes. Oh my word. Well, here's to hoping, right? I'm cooking off a little early here, but that's okay. Let me see. It's a gray marker. Michael, download my RAM? Happy New Year's. Alright, I like that. That's actually fairly creative. You get brownie points. That's fun. Excuse me a moment. One of these days, I'm not going to be making sick sounds on stream. Hopefully, potentially, sometime soon. That would be fantastic. In the meantime, I've got an industrial-sized bag of cough drops. Oh, ha! Alright, fair. Fair. Well, good. Roger. 10 for the flip flop. Alright. I'll take it. 10 for 10. Excellent. Okay. Alright, let me see here. Haha. I need. Gotta find it. Here. I need that one. Haha. Excellent. Oh, no ads. Of course. That's okay. We've got ads. And since there's ads, we'll pull back for a second. You know, it really kills me because I purposely have the ad rolls set so that they don't appear when you first join. I don't know how y'all feel about it, but I can't stand it when you join a stream and you're immediately hit with ads. But then you have that like you have that grace period where like you thought you were safe and then you're in stream, you're just about to say something and then you get hit with the ads and then you don't know what the streamer said to you when they said hello or replied to your comment because ads. I'm very sorry about that. They're not well timed sometimes. But I digress. What do we got here? Diagnosis. Replace the breathing filter. One could hope, right? Oh, yeah, no, I understand, Pyrex. Yay, back from ads. Alright, good. Hi, Pyro. Welcome on in, hon. Good, ads are over. Fantastic. I want to say, I'm pretty sure they're every 15 minutes. I would love to do the thing that other streamers do that help me know when they're happening, because unless you tell me, I don't know they're happening, because they don't appear in my thingy up top. I think I'm probably, yeah, it's probably if I was on a different dashboard, I'd probably know when they're about to happen, but I digress. I'm not going to waste time, because we got stuff to do. Haha. Fight me. All right, let's see here. We're going to go back into that one. Haha. Excellent. No, I know. It's just, it's frustrating because you want to see something, you know, be cordial, all that fun stuff. You get smacked in the face with an ad for like pizzas or something, and you're like, great, I'm hungry now, and now I'm sad. And it's like, damn, how dare. All right, so super fun fact: if any of you are mad enough to be following along with this 30 Days in Space thing with me, they changed their hosting provider. Now, thankfully, the old website points you to the new link, right? So if you look inside of your 30 Days in Space kit that they included, it says to go to inventor.io/launch. That is where you're supposed to go to get to the content. That will redirect you to craftingtable.com, as you can see in the top of the browser window. That is very much the new link for their hosting provider. This is loud. Why are you so loud? Hang on a moment. I think it's just that particular track. We're just going to skip over that one. Someone is mad as a proto. It's fine. But yeah, so they changed hosting providers. When they change hosting providers, they also reset all of your progress because they didn't bring over your progress. Now, funny enough, for my last broadcast that I did this, I already set up my new account with this domain, craftingtable.com, and then reset my progress to be back where I was. Wouldn't you know, when I was double checking everything last night to make sure that I'd be ready for today, I don't know what happened. I could not find my account or the login information for it. I'm really good about not misplacing that kind of stuff. So the fact that I couldn't find it was kind of heartbreaking. I'm like, I don't know what I did with it, but it's easy enough to just recreate another account. So fast forward to me making another account. I made a mistake. You're going to see here in this that I have completed day 10, even though we haven't done it yet. So I couldn't find a way to uncomplete a day once you've done it, because there's just the complete and continue. So we're going to ignore the fact that this is already saying we're on 11, because we're going to play with 10. 10's a creative day. So we are going to play a little bit of this jazz here. Jazz, I mean, we're listening to Chili DM. Or is it Chili DM? What station do I even have on right now? Oh, Lo-Fi. All right, close enough. It's next to the Chili DM. They're kind of in the same realm of space of time. Some things. Oh, great. That sounds like fun. 100%. I see. Factorio is a fun game, though, because there's a whole lot of just chaos involved in it, and there's a lot of laying out of the factory and the other little tidbits. There's a fair amount of thinking that goes into it, and then if you grow too big, you get attacked by the monsters. Or if you wander into the wrong areas. Factory must grow. Oh, God. Oh, Michael, you've played it? I've watched plenty of people play that game, but I myself have not. The madness is real. But yes, if you are following along, just be mindful that it is different. They did do it on purpose. They didn't carry over progress or your accounts, which it's a clean cut, but at the same time, there's nothing linking you to the content. Like, they're not gating it. You don't have any codes or anything. So honestly, it was painless to just make a new account and just click next a whole bunch of times until I got to the right day, and then blindly clicked the wrong button and then skipped a day. But nor here nor there. This is actually one of those things that I thought was a little funny, because I thought about doing this on my own, and then turns out it's actually day 10 on the creative, because when you work with photoresistors, right, that detect light, what's the most common place in a normal residential household that you will find a photoresistor? That's going to be a night light. When it's dark, it turns on. When there's light, it shuts off. So I was actually going to do this on my own, and then when I was reviewing day 10 to see what it was, because I figured they were going to wedge another creative day in here somewhere, that's actually what the creative day is. Now, the fun thing with the creative days, I skipped over the very first one because it was just toying around with the LED, and we already kind of, pushed pretty hard on that, and I'm like, I don't really see a reason to kind of keep digging into that. We already know what an LED does. We know it lights up, it's fancy, it's pretty, we get that. But at least with this creative day, we're working with the programming of making our own nightlight, but we don't get any code provided because it's a creative day. So you're supposed to be able to do this on your own without any additional instruction. Now, I am going to play a little overview here so we can hear it of their little tidbits, and then we're going to jump into it. So let me see here. I'm going to pause that. And then I'm going to come over here, and I'm going to go to that one. Okay, so you can still hear me. We're going to click the play button. We're on that one, and boom! Watch me get with an ad.
Hello everybody and welcome to day 10, the second creative day of the 30 Days Lost in Space Adventure Kit. I hope you're able to post your day 5 creative day successfully. We'll start by doing the same thing as a previous creative day. At this point, you are probably familiar with the photoresistor sensors and the RGB LED, since we just talked about those in the last couple of days. So here's a couple new projects that you can go ahead and try out for yourself. The easy project for this week, if you want to take on the easier project, is you can create a night light using the photoresistor. When it gets dark, the LED should turn on. When it gets bright, it obviously doesn't need to be on, so it should automatically turn off. And the harder project is to do the easy project, but then add in the functionality for the dip switch override. And of course, you're also free to do your own. So the last one is the open-ended option, which if you want to just do whatever you'd like, you can go ahead and do whatever you'd like. Once you're done, share it on inventor.io/Facebook with the hashtag CreativeDay10.
Ah, yes. So that is the tidbit that they've provided me for day 10. Now there is the option of using the dip switch. Science, indeed. As we have here, right? So there's the photoresistor, our fancy RGB LED, and the dip switches. I'm going to show you exactly the way that I would tackle this. And that is going to be reusing the existing code from the previous days. Because even though the logic of how this is going to work is kind of bouncing around in my head, none of the syntax on how I write it, I don't just have off the top of my head. So I'm going to end up opening up a couple of the previous days where we would have interacted with this, and you're actually going to see me jump or click through some of the daily broadcasts to figure out which days things were in, because when it comes to making something like this that I'm not fully aware of, all I did simply was just open the day just to get an idea of what we were going to do. I did not actually experiment or write any code yet, because I want to do it with you. Oh goodness. Hi Cozy. I hope you're having a good new year. Feeling for that new year shine. Hopefully it doesn't wear off too fast. Oh goodness. But yeah, when I'm working with building a project and I'm building off of something that I have, yeah, right, it's like little set of trees. I will reuse existing code to make the new stuff. There's no point in reinventing the wheel on how you've done something in the past. I love holding on to my older projects, especially if there's a chunk of the code that I know that will work great in a different project. I'll just open it, lift it, drop it in, and then adjust it to do what I want it to do, instead of rewriting all of it. No worry, Gray. Oh, Gray, the lurk command works again. I checked it. For some reason, the bot turned itself off again. I don't know what it's up and about. Regardless. So yeah. So you're gonna just see like my process of doing something that's well creative, which is why we're doing day 10. I'm not skipping it. And then we'll jump into 11. 11 is cool. We're gonna be playing with a new component we haven't played with before. I'm not gonna spoil it. But yeah, we're gonna do that. So. Okay, to jump into this, I have open the desktop, which is lovely. I have last broadcast available here, day 9. So, a little bit of a recap on what we did in day 9 is we put together a battery charger. I'm going to say battery charger. It's to simulate the idea of a charging battery with a status from the LED, right? So on the bench, we have with us the I didn't remove any of the wires, by the way. We've got our LED, right, which is currently green, right, to indicate that. And then we've got the photoresistor, which is on this side, tied up to our breadboard, right? And if I hit the reset on this, to restart the code, the way this example was made was to indicate 0 to 25% of battery capacity will blink in the red, right? And then from there, once we get above the threshold of 25, from 26 to, I think it was 50 is yellow. And then the example it gave us, there it goes, there it went to yellow. A little hard to see. That my overhead light on. It then said that green was supposed to be anywhere between 50 and, let me see here, yellow was between 25 and 50, and then green was anywhere between 50 and 100. I didn't like that, so I wedged an additional color in here that we already had. It was blue. So right now the battery capacity is between 50 and 99%. Because I don't know about you, green to me should mean that we're fully charged, we're ready to go again. So right now we are in the values of molecular terminal, about 72%. I'm going to carefully put this down, grab my flashlight, and I'm going to throw some extra light at this to quote-unquote charge the solar panel. Boom, and there's 100%. So now we're green again. That was what we previously did, right? So we already have the structure to make this a functioning nightlight. Specifically, the wiring is already set up the way we need it. So I didn't see the reason to disconnect shadow and smoke. No, Michael, I'm gonna be in a lot of trouble if I accidentally get smoke coming out of the box. Nor here nor there. Oh, and that's right, I keep forgetting about this. My head is behind the terminal here. So there's our 100%, right? And we're quote unquote fully charged, right? Because what we're doing in this example is, that little bit of a recap, is the photoresistor is our solar panel, right? That would be the way we're accepting power to put into our battery. We don't have a physical battery, and we're not physically charging anything. We're just simulating that idea with a photoresistor, because a photoresistor is incredibly similar to a solar panel. It accepts values via light. Now a photoresistor just returns a number, and a solar panel returns voltage, right, that you then pipe into your battery. So if we do a little review on our code here, and I scoot up a little bit here, let's see here, we declare our pins. My thought would be on the visor, Michael. That would make the most sense to me. Also, the back, funny enough, because if it's super sunny out, there's a surprising amount of light, and your back is already fairly flat for the most part. So that would not be a bad place to put one if you're actually trying to recharge the batteries of a wandering protogen that's wandering around. But that's my guess. I'm not going to go hard into this. I just want to briefly review before I start piecemealing it. We have our maximum battery capacity that we have here, and then we declare what the pins do. So they're writing, right, red LED intensity using the PWM. If I remember correctly, I believe that's pulse width modulation, I believe is what that stands for. Because the one thing that kind of blew my mind about LEDs and their whole ability to be not only different colors when you have a multicolored one, or just a normal LED, is that it doesn't like you lowering the voltage of the LED. So what you get with pulse width modulation is very rapid on and off of the same 5 volts of electricity. But by slowing up or slowing down that pulse, changes the brightness of the LED, because there's those brief drops in voltage, or the lack of voltage, and then quickly coming back. So the LED actually physically dims because there's that lack of voltage, and then the pulses translate into a dimmer LED. And if you space out the pulses a little too much, that actually causes you to get a fairly decent blink. Blink, 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 so on and so forth. So with running with that same idea, we normally wouldn't want an LED to blink, right? So that means that when it comes to our nightlight idea, our PWM, we're going to go with the idea of it just being on or off. We're not going to worry about adding a delay, right? Because the delay in the code is what adds the pulse to our PWM lines, which we don't really need that for this particular creative day example, day 10, right? So we're going to see that in the code, but we're not going to actually need it. We then have here our void setup, where we then declare what the different pins are. They're output pins, which means we're just pushing voltage out. We're not reading anything back in on these. And we can see here that we're physically plugged into pins 9, 10, and 11 for the LED. And that's declared up here. And then our serial monitor then actually gives us our values that's behind my head. Now, something I'm going to do is I'm still going to use the serial monitor so we can see the values, so we can kind of tweak this a little bit. And then we have our loop. That's void loop. What was the startup? Let me see here. That's the function display color. Right. Oh, there's the setup. So the setup is just this section right here of declaring the pins as output and turning on the monitor, which is again behind my head. Which I like that. And then we do some math. And then, oh, here's that delay I was talking about right here on line 65. So to make the red LED blink, right? Because I can make it a steady red instead of blinking. By just commenting out or deleting the delay of 20 milliseconds. But that gives you an idea of what causes the PWM lines to actually do that pulsing. Now understand something. If I plug one of these LEDs or one of the legs of our multicolored LED to an analog input/output, which are labeled on that board is a 0 through I think 3 or 4. I'm not sure offhand without looking at the board behind me. Those don't support pulse width modulation unless it's denoted on the board, which means that the code wouldn't work if we used a input or output that's on the board that doesn't support that function. Interestingly enough, we're hooked into it, but I'm also under the impression that unless the analog function would actually not compile, which I think it would. Let's see here. Right now, PWM output only works on the pins with hardware support. These are defined in the appropriate pins C file. For the rest of the pins, we default to digital output. Okay, so in the parameters of that function of analog write, it actually knows in the code which pins are supported of PWM, which obviously it would need to know for it to compile the code and actually work correctly. But I'm gonna be honest, I don't know if it would actually break the board if you plugged one of those into the analog. I think it would just not work correctly. I don't think any smoke would come out of anything. Honestly, I'm not willing to try, because without doing the research, I'm not willing to risk breaking it. Not intentionally anyway. Not without spare parts, which I do not have. So, with that thought in mind, what I'm gonna do is I'm going to start a new sketch. And then, no, we don't have any spares. Nice try though. Oh, did it? Wait, what? Oh, there it goes. Did it? No, it did not. Weird. It reopened the window once I saved it. Yeah, it's fine. Okay. Now, since the bulk of what I already need is a part of the previous project, I'm actually just going to copy that, pull it in, and I'm just going to start pulling stuff out we just don't need. Now, something that's important if you're going to do something like this to completely reuse code from a previous project, first things first, I need the serial monitor to not be hostage by the previous project. So I have to actually close this to be able to use it. So I'm actually going to close day 9, full screen day 10. I'm going to save that. And then before I do other stuff, I need to actually show the terminal, which I have to remember where that lives. Serial monitor. There we go. Okay, so I got the serial monitor back up. Now. So, I don't need to tell it the port. You do have to tell the port what mode you're running in, because the mode is either an output or an input. That you do have to tell it. What you don't need to tell it is if you're using the PWM function. On the board itself, physically, I don't think I'd be able to show you this because my camera won't focus. There's little dots next to which pins support the PWM, and it actually says the letters PWM right next to where the wire would go in. Sorry about that. I had a world of noise coming into the background, and I wasn't sure if you were going to be able to hear me, so I figured we just quick pause on that. Okay. Yes. Train of thought. Let me get back where I was here. We have. That's right. Yes, the PWM thing. The board has printed on it which ones actually support that. So to turn this project into a nightlight, this isn't going to be no ordinary nightlight. I have the multicolored LED still wired up, so we're gonna play with that idea. First things first, I don't need the concept of the battery. Now, currently the board is still running the previous code from the previous day, because I didn't clear it. I didn't reset the board itself. The code is still running. So the serial monitor is a part of the day 10 project, and it is initialized by the board, not by the compiler, because the compiler, I didn't verify or send any code yet. So what happened is that I opened up the serial monitor on here, but the board is actually sending that information because it's already in the previously compiled code on that board, dumping this set of numbers to the terminal. Something friendly to remember if you are going to modify a previous project. If it's something that's drastically different than what you were doing before, clear the code off of the board before hooking up all of your stuff. The existing configuration of the way things are physically plugged in right now are going to stay the same. So it's the code is just going to get reset on the board once I send it. But but you would not want to hook up your wires of an input to an output when the board is expecting an output and you give it an input. Yes, that would be a problem. I think it would just cause some weird coding. I don't think it would really cause any physical damage to anything, but just to not prevent, to prevent an issue for you later, clear the previous project off your board before continuing. Hi, Aset. Welcome on in, buddy. I'm glad to see you here. No, did it not work? Damn. Really? I thought it was the SO command. No, I'm gonna get this. I am gonna get better at doing this. I can't spell though, that's part of my problem. No? I'm terrible at this, oh my god. Come on. No, I'm gonna, you can heckle all you want. Did I get it? I did not get it. Well, I'm shouting out the Hedgie multiple times, and it's just not working for me. Pyro, if you're still listening, shout out a sec. I don't know what I'm doing. But that aside, oh, I had that written down. I don't know why that didn't work. All right, well, to get it, yes, Aset is amazing, does amazing art stuff, and has been doing several silly things on Twitch. By all means, please go follow them. Yeah, I'm gonna just chalk it up to that, because I swear that it was just supposed to be the shout out command. I'm being silly, and I don't know why. It's being silly. Oh, I'm stupid. It is, yeah, okay. I forgot it's not an exclamation mark. Thank you. So I could do that, and then Hedgie. I appreciate that greatly, Pyrex, because I don't remember my own commands. A whole bunch. Okay, beautiful. All right, thank you. Thank you, I appreciate that, because I don't know what I'm doing. I pretend to know what I'm doing, at least half of the time. Yeah, some of the time. It's not quite half the time. But yes, go follow the amazing artists, because they're amazing. And they do fun stuff. All right. I'm going to start dissecting this code and seeing what else we might need to pull over from a previous project. I've been waiting for 35 minutes. All right, cool. That's fun. All right, let's see here. So we need to keep the include Arduino. We are keeping our photoresistor pin, which I actually forgot to mention that earlier when I was talking about the pin declaration. This is the one for the analog pin, A0. That is specifically an analog pin, and the board actually starts with A instead of a number because it's analog. Shocking. Now, funny, there are other digital pins on this board that are also digital, but not PWM, which is what the little dots on the actual physical board are for. Nor here nor there. I still want it. I'm leaving it in the same place, and we're using the same pin. So again, I don't have to touch that. And then let's see here. I'm going to keep these exactly where they are. And then I don't need the idea of a battery. So this is going to go away. And then we're still going to keep our function for combining a red, green, and blue. Let's see here then. And then void setup. We're declaring those as outputs, which are going to stay the same. I still want the serial monitor because honestly, it's going to help me debug the values from the photoresistor, because we're going to have to do a little bit of tinkering to get the right values. It's a Luna. Hello. Hi, Bean. Welcome on in. I'm being goofy and talking about electronics on the internet as a toaster, which is another item of electronic based nature. I'm glad to see you. Okay, so I don't need the battery idea again, so goodbye battery level. We're not worried about you. You get to go away. All right, and then I don't need the battery math. That one I'm actually going to comment out because I might need to reuse that function, but I'm not going to nuke it. So by straight up deleting stuff I know for a fact I don't even need, I just deleted it. But for something I might want to reuse, the double / comments out the code so it won't run and won't compile. But it physically sits in the code in the compiler, so I could actually just copy this if I needed to reuse it. And then we're not doing anything with batteries anymore. So we're not worried about this if function. We're not worried about any of this battery math. That gets to go away. Okay, so this is the previous logic block for the different colors. So I'm going to partially gut this. So what I'm currently coding is day 10 of the 30 days in space kit. On my bench is the Arduino board and the breadboard. And the previous example was firing up charging a battery. So what I'm doing right now is I'm reusing the code from the previous day to build a nightlight using the photoresistor and the multicolored RGB LED that's already plugged into the board. That's fair. It's fair. I wait. Do I not have a height? I thought. Michael, do me a favor. Is there a hydrate redeem? I thought there was. I'm pretty sure I've got a TTS one too, but I think that one's broken. No, I don't. All right, well that's dumb. Hang on, I'm gonna grab a pen. See, haha, I have sticky notes. All right, no, I know TTS is off. I was working on it. I haven't fixed it yet. No, that's fine. Thank you. I'm gonna add a hydrate redeem. Yeah, it's funny. I thought it was strange that no one ever used it. It's shocking. I don't have one. Oh, it's terrible. It's not my fault. Yes, it is. It is 100% my fault for not having that redeem. What can I say though? I suppose it'll happen. I don't know. It's fine. I'll have one. I don't know. We'll need to choose a sound. All right, that's fine. Someone remind me when we're done talking about science. We're going to talk about that hydrate redeem because I'm going to need to come up with a sound. It's fine. It's fine. Yeah, Panic. We are talking about Arduino and doing stuff and making lights blink. Let me see where I'm at here. All right, so I truly don't need the if blocks anymore. So what I'm going to do is I'm going to strategically gut out the if statements and the structure that goes with it. Yeah, you better believe it, Blinky Blinky. Because I don't want to nuke what the colors were. So I'm going to gut that, I'm going to gut that, I'm going to gut that. So right now that leaves me with these different colors, but nothing preventing them from doing one thing or the other. Okay, so what I want to do, I gutted this, so that doesn't do anything right now. Do I want the delay? 1/10 of a second, so displayed values don't scroll too fast. Actually, I'm gonna keep that delay just so it's readable in the terminal. But instead of reading percentage, I want to read the raw value of the photoresistor. So I actually want to read that value down here. So what that will do is that will show us, I don't need the word percentage. Let me think about how I'm doing this. I actually want to use the new line, so actually we're going to gut this a little bit more. because I want the value and I do want the new line. So we're actually going to reuse that to get rid of that, to which then will spit out. This will display the value of the photo store, and then that will that will give us the value, the raw value of that, because we're not really concerned with any kind of idea of a battery anymore, because we're just gonna make the LED turn on or off. Hi, Blackon. It's okay, Set. This hopefully will make sense once I'm done gutting the previous project. I apologize for not really describing what I'm doing here, but once I get it to the point that it makes sense in my brain, I'll be able to actually explain what I'm doing here. There's a fair amount of thought and then talk that comes with doing this. All right, I don't need red, so I'm gonna actually just get rid of that altogether. And then I'm debating, well, a white LED would be all the colors, right? So let's do that. So the maximum value of these, I believe, is 255. Yes, the intensity is 255. Yeah, no panic. I totally get that. If I had, so normally what the way this works is that I have the code with me, and then I can explain it as I'm building it and showing it. This is a creative day project, which means I don't have any code to work off of, so I'm reusing previous day's code. So the idea of trying to explain it while I'm trying to figuring it out at the same time, I might short out something in my head. And I'm really not trying to look like this, but I kind of feel like that's where I'll end up if I try to do both at the same time. So yeah, we're going to have to be a little careful with that. All right, so 255 is our maximum value. So I want, oh, hang on, undo. I don't know what I did. I'm undo it. I did not see where my cursor was. There we go. Okay, so yeah, we are going to do the color white. So we're going to do, all right, so for those of you, nope, I'm dumb. Hang on, 255. I want this to be blinding levels of bright. It's a nightlight. A nightlight would, of course, want to be at full charge. So this is full brightness of the color white. Because you will get white when you put all three of the LED's primary colors on at the same time. The previous example worked through cycling through a couple of different colors. Well, nightlight can be multicolored, but in our particular example, it's just going to be on or off. We're not going to try to do anything fancy because I do want to get into day 11 as well. That looks like fun, so I don't want to drag this part out too hard. Now, right now, this is not done. So I'm gonna save what I'm doing here. There we go, I've saved. So right now, as the code is currently written, we know which pins are red, green, and blue. We have a function to call that will take those three numbers that I've manually set, right? Now you could actually have many different things to change these values on the fly, or even get input from a user to change. These are all hard-coded values, which means they don't change in the code. Nothing can change them because they're manually typed in here. I'm kind of hoping as we progress through this 3 days in space thing that we'll get something to get a little bit of user input to change some numbers around, because I know how to do it in PowerShell, but I don't really know what I'm doing in here. So well, that's why we're learning together. Shocking, I know. All right, so right now we've got that declared. We can call it to change the colors, and then it'll actually do it on the pins. Our setup is to make sure that we have them all set to being outputs because they're going to make the pretty colors come on for both red, green, and blue. There's 3 different colors. Come on, hands, do the thing. Nope, we're trying. We're trying so hard. 3. There we go. We've got 3 separate colors, and when they all come on together, we're going to get white. Okay? And then this is going to show the serial monitor, which right now, once we start our loop, there's nothing controlling the LED. It's simply going to turn it on at white. There's going to be nothing to change this right now. I want to make sure that at least what I've put together so far functions. And then we'll proceed to finish actually making it a nightlight. When I code anything, the whole idea is to check and compartmentalize what I'm doing into chunks. Because when you're building something, say like a brick wall, you don't build the entire brick wall in one setting and then check to make sure you did it. It's going to be all kinds of messed up. You put together what you have, check it, and keep going. Take a couple more steps, check it again. That allows you to sniff out stuff that you may have missed, and also making sure that you're on the right path. Because if you don't click the compile and run button several times through building the project, you're going to leave yourself open to quite a few surprises. Okay, so the reason that the photoresistor is declared as an input, I realize that's kind of a little confusing, is because we're reading the value of the light that is hitting the photoresistor. So the value I'm reading is being brought into the board, not the board pushing something out. The idea of the LEDs are outputs because we're manually telling the legs on pins 9, 10, and 11 to push out voltage and pulse at a certain PWM. Now in this case, we don't have any delays, so it's just going to be a constant stream of 5 volts shot out to the board. Now hang on. Now panic. Is that before or after a fireworks incident? Because you know, even if you have them all, yeah, it could be less than 5 by like a lot. It's terrible. So right now, I'm expecting this to do a couple things. I'm expecting our LED to turn white, and then for it to tell us the value of the photoresistor. I'm going to hit it with a flashlight. I'm going to move it so it's out from behind my head, and then we're going to make sure that the initial framework functions. So before I do anything, I'm going to validate the code. So I can click the verify button. It's going to compile a sketch. If I made a syntax error, it's going to tell me. Okay, it has done compiled. It didn't bark. I don't have any red lines. So I didn't miss removing any of the curly braces or the parentheses. Those kind of things are important to just watch out for to make sure you didn't accidentally miss something when you're gutting a previous project. It's very easy to copy a block of code. It's a whole nother thing to make it actually work the way you want it to. Now, so far I have yet to send the code to the board. So if we look at the board right now, it's still green, because in the previous project, the code was set to count up to 100% and then turn green when it was at 100, right? So I am now going to go back over to the code here, and then I'm going to push it. We should get a white LED, and we should start to see different numbers in the terminal behind my head, which I will move. So I'm going to push that. It's coding, and we are going to see now in our serial terminal a value of 14. Now, I'm going to grab my flashlight, I'm going to shine it at the photoresistor, and that number should go up. Nothing is happening, so that means I didn't put something in the correct place. Now, that's okay. I think I know what I did wrong. But before I check that, we're going to look at the bench. And it is incredibly difficult to see because of the exposure of that camera and spacing. Let me pick it up and see if I can make this easier to see. It is currently on white. All of the individual colors are illuminated, which means that as far as the code's concerned, I put this over my hand, Even that's kind of hard to see. Hang on, let me hit the light above my head. See if I can make that a little easier to see. Kinda. All the LEDs are on. There is blue, there's the red, and the green. And you can actually see a little bit of overlap in the colors. If I maybe do that. Nah, the exposure on this camera's crap. I'm sorry. But I can tell you right now, all of the LEDs are on. Or excuse me, all of the legs are on and at full brightness. So that part is functioning. This LED is on and it's the color I asked it to be. Now, I'm not getting a value of anything more than 14 because I think I might have put the reading for the photoresistor in outside of the loop, which means it only checked it once, and it's only ever going to get a number 14. So let me switch us back and take a look of what I've done, because I've clearly messed something up. So let's see if I can figure out what I did wrong. So we can see down here that we've got our void setup is there, the serial's there, the void loop begins here. Okay, so I specifically asked for the value of the photoresistor pin, but it's not a part of the loop, which means I only ever got the initial reading of the photoresistor and then promptly killed it. Now, indeed, Panic, you can see the thing I commented out that I kind of needed. It's funny because I thought I was going to need it, just not in the sense that I did, but that's okay. So, I'm going to uncomment that, and I'm going to partially gut this. It's not a battery, and there's no running tally, so that part I can get rid of. But what was important that I didn't do is I never reread the photoresistor pin. So I'm going to clear that comment because that's unrelated, and this reads the value of the photo resistor. Now I'm going to save that. And now I'm still going to get a continuously white colored LED because we have yet to do anything that prevents that from changing what it's doing. It's just on constantly forever. And then after it's red down here, I have it spitting out that value to the console. Now, Panic, it's perfectly fine. This is not anything like a game. If anybody in chat sees something that I've missed or commented out, it's perfectly fine. I'm not going to get mad. It's completely acceptable. This is quite literally a learning environment. I am learning with you. Enough said. Now, I'm reading it. I would prefer to actually also display it and actually have it be a part of this up here. And then I'm going to get rid of all these comments because they're not related to what we're currently doing. So we've got right here that we're going to read the pin. We're going to then send it to the terminal, which is down here behind my head. And then we're delaying by 1/10 of a second so that we can actually read the numbers. This delay doesn't do anything other than slow down this code loop by 1/10 of a second, but it makes it easier for us to read what is spitting out to the terminal. I'm going to save that now. I'm going to verify it. And then I've only compiled it. I haven't sent it to the board yet, so nothing has changed quite just yet. I'm going to shoot that off. And now, if I did that right. No, I still messed it up. Oh, that's a good point. Yep. you're right. I am reading just straight pin, which means I need to store it and then display it, because otherwise I'm just reading the constant. You know why? Because that's pin 14. I'm actually reading the pin value. Because if I go back up here, A0 is pin 14 on this board. See? Value 14 or 0xe. Yep, nope. that's definitely where we're up to there. So now we're going to verify that. I didn't declare the variable right. Let's see here. I didn't declare it in this scope. I don't think it's the dollar symbol. Let me check. Nope, doesn't like that. How do you declare in here? We've got... Right, that declared that as a byte. Red intensity, that's a part of that. That's the constant. So actually, no, it's not supposed to be the dollar symbol. I'm supposed to declare it before I use it, which I didn't do. Yeah, well... It's between 0 and 255, or no, wait, it could be more than that. The photoresistor is going to have to be a... I think it could be an int, but I need to declare it as such. Which I don't want to declare it down here, I want to declare it up here. Because I don't want to declare it in the loop, because that would just reset it each time. So in the void setup, we're going to declare... Actually, I have to do that up here. I don't want it. I want it to run. I want it to declare it once. So it is going to be an int of photo pin, and then it's now an integer. I don't believe it would need to be unsigned because I'm pretty sure that this only returns whole numbers. So let's recompile that. Nope. Well, what did I do now? Expected initializer before display color. Oh, I didn't equal this to anything, so we want to be equal to nothing. There we are. Okay, so now that that's happy, that compiled, we should get some values now. I like that it didn't go back to the serial monitor. That's better. All right, that's actually about right because this room is kind of fairly lit. Okay, I hit the flashlight again. Aha, we got bigger numbers. That's better. All right, beautiful. So, this is where I mentioned that it's going to be a little bit of toying with the code. There is the idea of every room being different levels of brightness, right? Because if you're in an exceptionally bright room, then that value is going to be very large. But if you're in a kind of semi-dark room, then the values you're going to get are going to be lower. So the question you have to ask yourself, if you're hard coding some numbers in here without accounting for the ambient light in the room, which we have done in a previous example, I'm not going to do that here because I just want this to either be on or off based on a hard coded number. You have to dictate what is considered dark enough for it to come on. So what that means then is we're going to add our conditional statement around when this comes on. And then we also have to add the logic for it to shut off again. We want it to turn off when it's dark. Let's try that again. We want it to turn on when it's dark, otherwise it wouldn't be much of a nightlight. And we want it to turn off when it's bright in the room. Right, so it's fairly bright in my room right now. Let us see. Let me hit the light in my overhead light and see how much these numbers dip. That will give me an idea of what we're working with here. So right now we're in the range of 60 to 70 raw numbers from the terminal. Light. And we've dipped into the 30s. Okay. Now something that's kind of funny is that the LED is right next to the photoresistor, which means that it's close enough on the board that might cause us some trouble, but we'll see if this works out. So let's say that once it hits, I'm seeing 30s. All right, so we know for a fact that in this room, okay, so we have an idea right now of the ambient room light. Feedback loop. Oh? Do you hear feedback right now? Okay. I immediately thought of audio. No, you're right. With the light being so close to the photoresistor, it might give a little bit of feedback. I don't think it'll be enough to cause a problem, but we'll see here momentarily. Okay, so I add some comments above what we're about to do to give us an idea of at least where the values are in this particular room. When it's bright enough in here, we don't want it on. The values floating around 70, we would want the light to be off. We would want the brightness to be in around 30 from the photoresistor for it to come on. So what we're going to do is we're going to add an if-else statement to dictate when we want it on and when we want it off. So we're going to say if the photo pin is less than let me think about this for a minute. So it was around 30 when we would want it to come on. So if I said it was less than 35, that would give us a little bit. All right, I'll take 32. Less than 32. Then we're going to ask for it to come on. Else I want it to be off. So So I'm going to just steal this. And then to turn it completely off, I'm going to switch the 3 color values to zeros. Like so. Now what's going to happen is that there's going to be a very brief delay of this particular if statement because of this delay that exists up here in the code. Now, something that all my professors always told me is to never add hard-coded delays to your code, because every delay you add accumulates and slows the execution of the code. In our particular example, we're trying to read the output of the terminal. So this is one of the few times that a delay makes decent sense. But hard-coded delays are generally considered a no-no in most applications. It's perfectly fine for debugging, and it would almost be worth it to, put this delay in a debug if statement so that you could actually manually toggle it on and off, so that production gets no delays and debug gets the delays, so that the code actually runs more efficiently when you're not looking at this terminal. Nor here nor there. These are pretty basic examples, but if you're going to push something to production, less delays, hard baked into the code, unless there's a reason for it, the better. All right, so I'm going to compile that. Oh, I made it mad. To the 5th is 32. Fair. Yeah, delays are a big no-no. What did I do here? I missed a paren, didn't I? Photo. I missed an O. Ah! Bite me. Yeah, that's better. Okay. Now that I've done my damage, I'm going to send this to the board. Yeah, you gotta love typos. Okay. Now, I pushed the code, and the light is currently on in this room. So right now, as you can see, the LED has turned back off. And if we take a look at our terminal, we are getting values in the arrangement of 60s, just floating below 70, right? And we want it to illuminate if it's less than 32. Right, that gives us a little bit of buffer. So I am going to flip the light again, and we should see the LED come on. Okay. Now, do you all remember when I mentioned not putting hard-coded delays into your code? There's a reason for that. I had a funny feeling it was going to do that because I left the hard-coded delay in there. We're getting values that are low enough to cause this to actually increment. These values are less than 32. But there's a problem we've caused ourselves. We have a delay of a millisecond. So that delay within the loop is causing the code to pause briefly. So by making the delay go away and sending it, serial monitor is going to go really, really fast. It's actually still kind of blinking. I think that's because of the values are floating really close to 32. If I adjust that and give that a little bit more wiggle room, it's really close. It's set to 36. Hmm. What we're getting right now is no more blinking because the values aren't floating around that cutoff mark, and I've removed the delay. So if we take a look back at the code, you can see that my photo pan I have set to 36. If it's less than 36, turn it on at full brightness. Otherwise, shut it off. Each time these are coming, they're now no longer so close to the threshold, it's not blinking anymore. I've commented out the delay, right? Now, I am curious. If I put the delay back in, will it blink? Well, maybe it won't. We'll see here in a minute. Code reinitializing. It's not blinking. The blinking was actually because of being so close to the threshold of what was considered on and what was considered off. So now this is a functioning nightlight. I'm going to turn the light on and off in my room a couple times, and we're going to see it turn off and turn back on again. Room light is on, LED is off. Overhead is off, LED is on. Funny enough, it's very responsive in that regard. It does work. It works incredibly well. Now, we have successfully completed day 10 of making a nightlight. I'm not going to introduce the idea of a manual override for that, because I do want to move on to day 11, and yeah, we're getting kind of deep into this. So we're going to move on to the next part. But yeah, so that is the idea of the nightlight. I was saving this along the way. I'm going to save that again, actually. Save the code. Aha! Yeah, I suppose it doesn't have to be a very quick on or off. Because, I mean, if you think about it, in the code here, I just have it set to full brightness, right? So, realistically speaking, if I wanted it to fade off, actually shouldn't be too hard to do. Because it runs through the loop, right? So if I actually just took this, bump this down, and say we go from full brightness to half brightness, and then off, it should actually fade out instead of just hard going off. Now that is going to cause probably a little bit of blinkage, but I'm actually kind of curious to see what that would do. So we're going to try it. We're going to go back to the bench camera, and I'm going to compile it. I didn't miss any semicolons. I'm going to send it. Send it, baby! Alright, so right now, the values of the room are in the 60s and 70s. Oh, I'm seeing some blinkage. Oh, it's really, really exceptionally low blinkage. That's interesting. So if it's less than 36, why am I getting blinkage? Those values are above that number. Interesting. Why would it be doing that? If the photo pin is less than 36, those values are above 36. Less than 36. Full brightness. I think it's the way I wrote the logic that's causing it to do that. if the photo pin Alright, let's toy with the if-else statements. I think I'm getting blinkage because of the way I wrote it. So if I take this if statement, so photo pin being less than 36 is full brightness. So right now the values are not less than full. So what's actually happening is it's falling into the else statement and we're getting the blinkage because there's the only other thing this can do is either be full brightness or partially blink through these other brightness levels. So I have to actually fix this by saying if this is, I want full brightness when we have darkness. So if it's less than 36, I want full brightness. And then say if else, or else if. Photo pin. No, because even if I do add the additional conditional to this, oh, I am on the wrong source. There we go. Yeah, I'd like you to see what I'm doing. Right. So right now I have if for less than. See, the trick here is that. Actually, I'm gonna undo that. Right, because to fade out when the room's too bright, I would want it to eventually stay off. So it can't be in here constantly, otherwise it's going to blink. Because it's going to go from max brightness, half brightness to off, and then just keep cycling through that because the value is not less than 36. Because it's either less than 36, which is full brightness, or the other conditional, which is always true, is to blink, right? Because it's not going to fade. So let's think about this for a minute. I would want the actual case of being truly off to be its own thing. So if we are less than 36, it's just about the transition of going back to light, right? Because briefly, it's between, I need my notepad. I've been given a challenge and I think I can make it work. The room brightness is at 70 when it's on and we're floating around 30 when we're off. So the values between, I said 36. So from 37 until 65 is the transitional period of the lights coming back on. So let's actually add that in here. So if we say else if photo pin is I don't think I've done an example that does between in the Arduino project. So this would have to be greater than 37 or photo pin is less than 65. I believe the or is the double pipe symbol. If that's not right, I'll have to look up the syntax. We're going to briefly go from full brightness, half brightness to off. And anytime you have an else if in a block of if the else if statements, you need to end in an else. Otherwise, you have code with a hole in it. So then what we're going to do there is add the else. Otherwise, we want to just shut back off. Yep. I wanted to tab. Come on now. All right, so if this works the way I think it does, if we're in darkness, we come on full brightness. If we're in the transitional period between being off to on, we're going to then fade from maximum brightness to half to then off, and then you're going to be back up into like, right now we're in like 60. Actually, let me do like to like 60 instead. Anything above 60 then is outside of, it's not less than 36, and it's outside of this range, which means we will just stay off. So we should see actually a little bit of a blip or change in brightness when the lights are transitioning between on and off, if I did it right. I messed something up. What did I miss? Let's see. Else if was not declared. That's the way I wrote this that it's not happy with. So we're thinking it's the other way around, if else. Let me look at day 9. Day 9 had a cascading statement in it. No, where did I save these things? There we go. Day 9. Let's take a look at a functioning example. This might get a little upset because I already have a call for the serial monitor in the other one. Oh, there's a space. Else space if. Okay, that's fair. Like that. That'll do it. Okay, so I'm gonna send the code. And right now, the light's off. Oh, no. I said that and then it started blinking. Let's take a look at the code. What did I do now? Is it greater than 37? Technically it's greater than 37, so it's falling into that trap. Alright, let's do it this way then. Because the transitional period would be technically less than 60, but it's going to be greater than 36 because the light's coming back on. So let me actually change this logic out for that, which should make it a brief interaction instead of a constant. That's better. Let me show you what I did. I was on the wrong source. This is now else if the photo pin is less than 60, because it's going to be greater than 36 when the lights are on the way back on, but as long as it's less than 60, we're in the process of turning back on. I've gotten a raid. Oh my word. King. King, hello, King. King, I am melting everyone's brain, including my own. How are you doing this fine evening? Welcome on in, Raiders. I am TechHead41. I do what you're seeing right now on the screen. I do technology stuff, and I do madness. King, what were you guys up to? Was it VR chat? Were you doing something else? You kicking butt, enjoying the new year? All that fun stuff? I'm in the process of making lights blink in varying levels. I am curious. You get in chat what you were up to, and I'm going to turn the lights on and off a couple times, and we're going to see what happens here. All right, so we should go from full brightness in the dark. I hope. Assuming I haven't completely bricked the code that I've written. Okay, good news. We are currently full brightness. Our values are floating around 25, 26. When I turn the... Now this is going to be probably kind of a quick thing. How quickly this is going to transition, but we should see it fade out briefly. Nope. I think that's in part because I don't have a delay. I just gave you the rant about not adding delays to the code. I think I'm going to need to for this to be visible. I think because it's just going straight through, we actually physically can't see it because we're not giving it enough time for us to visually see the difference. So against my own terminology here, I'm going to add a delay in here. And it's going to be a bit of a hefty delay so we can see it. Let's see here. Let's do like 300 milliseconds. I think that'll make it visible. I hope. Well, thank you, King. I appreciate the raid. I'm glad you have stopped in with your audience. I will show them many things that blink in wires. I'm probably going to melt some brains, including my own. All right. Let's see if that makes a difference. Okay. I think it is behaving slightly differently. I'm just going to make that a really big delay and we're just going to see the difference. We're going to make it a full 3 seconds. I'll reset the board. I'm going to try to make it obnoxiously large so we can see this. Nope. Interesting. I must have missed something. The neighbors are going to think I'm out of my mind. Not that they probably already don't. Okay.
you're up. Hope you're ready for the dawn of a new day in this damp tin can that we're calling home. Week 3 already, huh? Seems like just yesterday you were fumbling over the basics. Look at you now. Power, light, a snazzy RGB battery indicator. All pretty impressive, I must say. This week we're shifting gears. Enough.
Okay, testing 1 2. Testing. Can you hear me now? Says the thank you. Fantastic. I think my sound card acted up because when you said you couldn't hear me and I was seeing device input, I think the control panel locked up. Good times. All right, now we're going to continue the video.
Ah, you're up. Hope you're ready for the dawn of a new day in this damp tin can that we're calling home. Week 3 already, huh? Seems like just yesterday you were fumbling over the basics. Look at you now.
Still kinda
Power,
hard.
light, a snazzy RGB battery indicator. All pretty impressive, I must say. This week we're shifting gears. Enough with the basic survival needs. It's time we brought this old ship back to life. Our goal is to fix up that control panel, whose appearance looks as if a Martian tried to play tic-tac-toe on it. To start us off, we've got a new tool to familiarize ourselves with. A 4x4 keypad. I know, you must be thrilled. Do try not to let its looks intimidate you. That's 16 whole buttons of potential inputs at our fingertips. Alongside our new hardware, we've got a new concept to grasp. Brace yourself, because we're diving into the wonderful world of libraries today. Think of libraries as your ultimate cheat sheet, shortcuts that make coding easier. So, don your programmer's hat, take a sip of that dehydrated coffee, and let's tackle the day ahead. We've got work to do, Explorer.
All right, hold on a minute. She dehydrated coffee. Am I just munching on coffee grounds or instant coffee grounds? I don't know, man. I don't know.
All right, let's chat about our new piece of hardware, the 4x4 keypad. Each button, when pressed, closes a circuit and sends a signal that we can detect and utilize. It's similar to a keyboard you might use on a computer, but far less complicated. These keypads
Seriously?
are often used in security systems, door entry systems, and all sorts of devices where manual input is necessary. Today, we'll be using it as a control interface for our spaceship. The real magic happens when each button or key is pressed. A unique combination of 2 connections is made. One connection from the 4 row pins and one from the 4 column pins. This allows us to know exactly which button was pressed without needing a separate input pin for each button. Each of these 16 buttons can serve as an individual input, providing us with a wealth of potential interaction options. I can see it now. We could set a code to trigger a certain action, or assign different tasks to different keys. The possibilities are vast and are waiting to be explored. This also means we can reduce the amount of input pins needed from 16 to 8, which is important when we have limited pin real estate on our hero. But before we dive into all of that, let's get this mighty piece of machinery wired up and running, shall we? My, that was quite easy. Looks like we can skip the breadboard entirely today. Speaking of easy, let's hop on to our next coding concept and explore the power of your new partner in crime, library.
Okay, all right, that's fine. Before I let that continue, we are going to hook it up. So before I switch scenes here, we could see briefly that was mentioned. Actually, here before I jump into that, I do want to mention the. Remember earlier I was talking about the PDW, pulse width modulation. This is what I was talking about in the diagram. Pins 9, 10, and 11 of our currently wired thing that we're doing with the LED. That little tilde, the little squiggle that's next to the numbers, indicates which pins have the PWM support. As you can see, pins 12 and 13 do not, because they do not have the squiggle. 9, 10, and 11 have the squiggle, so they support the pulse width modulation function. And then our analog pins live on the complete opposite side of the hero board. And there's a total of 6 of them, 0 through 5. Now, as you can see here, as she briefly mentioned in the example, that there's a total of 16 physical buttons on our keypad. But we can see that there is 1, 2, 3, 4, 5, 6, 7, 8 wires to turn into 16 buttons. And that's because of the way that the keypad is wired. Now, let me switch scenes, we'll get it wired up, and then we'll keep on trucking along.
Okay. First things first, like any other time where we mess with the breadboard, I'm going to disconnect it from the computer. There is now no longer a physical connection to power to the circuit, which is great because I don't really want to fry anything. Nope. And bring chat over here so I can see you guys. Oh, there we go. All right, good. So what's going to happen next is I'm going to disconnect what we have currently set up because we are done with it. I'm not gonna lie, it makes me a little sad when you disconnect something, but hey, we're gonna make something new. But that's okay. So we are currently done with these being hooked up where they are. So that disconnects all of those wires, which I'll set aside. Something else I'm just going to briefly mention. As you can see here, the LED and the photoresistor were both not directly connected to the hero board. There are these 3 resistors at, I believe it's 220 ohms. Let me double check here in the paperwork, because it does tell me. Yes, 220 ohms of resistance. I was correct. I like double checking because I like real information, not that made up stuff you find on the internet. I don't know the color coding off the top of my head because they are color coded, which does help with that. But yes, so the pulse width modulation goes to the positive side, which is tied to the resistor to prevent both the photoresistor and the LED from drawing too much amperage and burning themselves out. This just simply protects the component. It is included in the diagrams when you're hooking these up, but it unless you know, you're going to burn the parts out. Which is why it is important to follow along with the directions. Which is nice. So yeah, there's the legs of the little guy. And then we're gonna get all these out of here. Which actually I'm just gonna set this aside because we're not using it as of right now. I'm just going to put both of these components off to the side. And we're going to continue on with the lesson. That over here. Now, that's going to involve me finding the keypad, which is in here something. Nope, that's the display. You got lots of stuff here. So that's the display. And there we are. So I'm looking for that, and then I have to see how this is wired to the rest of the things here. Give me one moment while I put those other 2 components away so they don't roll off my desk and disappear into nothingness. I'm not best, I'm just half decent to good at what I do. Now, as you can see here, this is our display, and it does come in this foil bag. If you're not familiar with computer parts, this is known as an anti-static bag, which prevents static electricity from working its way into the components, which I'm going to just cut one side off, slide it out, and then when we're done, I'm going to slide it and put it back in here. That way, it's protected from from static, discharge, which will happen if you are working on raw components. You want to make sure you don't accidentally zap your stuff. So we've got that right there. Now there is something that is important about the way this is being hooked up to our board that's different than any other component we've worked with thus far. There are standoffs here. That's what these, help me put that in frame. These are standoffs, which are these little guys right here. Which means that our standard wire we've been using this entire time has been male on both ends. It's got the silver, right? But this, obviously, I can't press on top of that. That doesn't work. So what I need is I need to use a different kind of jumper wire, which is perfectly fine. They did include them, and that's this set right here. So it's got the connectors, the male end on one side, the female end on the other, and this allows you to connect this button board directly to our breadboard without having, our hero board without the need of the breadboard, which is a little dude that I set aside. So I need a total of 1, 2, 3, 4, 5, 6, 7, 8. Now, if I take a look at our colors here, got 1, 2, 3, 4, 5, 6, 7, 8. So red is where we're going to separate like that. Now, I'm going to try my best to not mix up the colors as I hook this up from left to right. So this is the part where we're going to be a little careful as we work this on. Now, when you're building a computer, this is probably the most nerve-wracking thing because it's the front I/O, which is usually the power switch. This is going to be very difficult to do. I'm going to have to actually spread these a little bit. Let's see if I can convince you into an order that I can actually plug you in. We're going to try. Oh, this is going to be difficult doing it this way. How difficult do I want it to be? The answer is yes, apparently. I suppose if I get some of these on here, and then work the other ones on, go about doing it that way. Like so. Alright! Okay, so now I've got our wires connected, and I kept them all pre-assembled, and then we've got our other end that we have to actually hook up to the hero board, which we're going to attempt to do. And it looks like I'm not skipping, according to the diagram, I'm not skipping any of the wires. I'm going from port number 2 all the way up to 9, right in order. So we need to go from 2, which is right above transmit receive, straight up to 9. So let's see, that's transmit, that's receive, and that is plug number 2. And I just have to be careful that I plug them all in the same order, so they're the same on both ends. This part's going to require a little bit of patience, but that's okay. As I work on getting them plugged in. Okay. Now I'm hooked up to pins 2, 3, 4, 5, 6, 7, 8, and 9. And I'm looking at our little numbers right here. I'm about as safely plugged in as I can get. And then this is all a digital read. So that is what we're working with. We got a nice direct connection between our buttons and our hero board. Now, before we continue, I am going to start a new project and send the blank project to the board to clear all the old code off of it. I'm not going to hook that up yet. I'm going to get that prepared first.
So I am going to start a new IDE project. Folder for day 11. Yeah, I'm going to close out day 10 because we're all done with that. Since we're working with buttons and we're going to need to see our output, I am going to turn on the serial monitor again. Okay, so I've got that turned on. There's currently no code in here to do anything. It's just a setup and loop, and they're both empty. So I'm going to connect the board. I'm going to then send this to then clear the previous project off of the hero board before we continue.
Now, before I click the button, this is getting some strange readings.
Our previous project is hooked up to the buttons, and it's returning some very strange values in here. It's no longer hooked up to the photoresistor. It's hooked up to those buttons. And what my guess is, I believe this is probably the resistance of the circuit that it's returning, because they're about the same numbers. This is what I mentioned about clearing the previous project, because if you forgot to do that and you're looking at the serial monitor, you'd be like, what on earth is any of that? So I'm just going to upload it. Now, as it stands, the numbers have stopped, but there's still this stuff in the serial monitor. That's only because it hasn't been cleared. Now, I manually cleared it and the numbers are gone. So now the board is back to being a blank slate. There's no code on it, other than just the simple setup and loop with nothing else. So if we switch back over to the bench camera, you will see that the status indicator light is that it's got power and it's not doing anything else as of right now. That is our wireframe to start the day 11. So I'm going to switch us back to the video. We are going to listen to our description that's left, and then we're going to dig into setting up the code that goes with it.
Libraries. In coding terms, a library is like a prepackaged set of code that provides specific functionality. Essentially, they give you a lot of new functions to use and make your life easier. Now, let's talk about the new library you will need to install, the Keypad library. This is a custom library designed specifically for interfacing with keypads of various sizes, like a 4x4 keypad, for example. How convenient! It includes functions for detecting when keys are pressed, which keys are pressed, and even some advanced functionality like multi-key detection. By using this keypad library, we can simplify our code and kick our level of efficiency up a notch. Because who needs more complications when you're trying to repair a spaceship, right? In order to use our library, we'll first need to install it. If my calculations are correct, there should be a link located somewhere, cached on your current computer page to a zip file. Download that to your computer, and then, in the Arduino IDE, navigate to Tools. Then, Manage Libraries. Then, add Zip Library and select the newly downloaded zip file. Take all the time you need, preferably as quick as you can. I'll be here waiting patiently for you when you return. You finished? Wonderful! Let's continue, Explorer.
Okay. All right, so we have to go get the library, which, look at that. All required libraries resources can be found right here via the really big download link, which is funny because it's using their old domain, even though they're crafting table now. But that's okay. We are just going to open that in a new tab, And we need to get the library for the keypad. Is that a 4x4? Is that right? 1, 2, yes, it is 4x4. So I'm going to get that library. And then we're going to go back to our project, tools, and we're going to manage libraries. Oh, no, that was this one. All right, well, we have to add it. So we're going to do that. These are all the ones I can just add directly through. But I don't want to do that. All right, hang on. I have to look up how to do that. Open your Arduino IDE, click on Sketch, include library. So Sketch, include library, add a zip library, haha. Okay, I went to the wrong place, got it. Downloads, 0, and open. Haha, look at that, the library's been installed, fancy. Yep, and I just got the notification down there in the lower. Alright, beautiful. Beauteous. It's all about clicking on the right place at the right time. And that, yeah, that's part of figuring it out.
The library allows us to accomplish another new practical task, and that is to create a new, unique object, a keypad. It also adds in functions like getKey to tell us which key is being pressed. In order for the newly installed library to help us, however, we need to first provide it with some relevant information. Here is our list of to-dos. We need to tell it how many rows we have, how many columns we have, the pins that we are using for our column pins, the pins that we are using for our row pins, and finally, we need to create a key map for the buttons. Whew, that was quite a mouthful. Well, we know we have 4 rows, 4 columns, and we can take a look at which pins we're using by simply looking at our wiring diagram. Next, we have to make a key map. We can achieve this by utilizing a pair of new data structures in programming, arrays. In the realm of programming, an array is a data structure that allows you to store multiple values in a single variable. Imagine it like a storage box with multiple compartments. You can put different items, or in our case, data values, in each compartment and later access them using an index. An array is defined by the type of data it can hold, like integers, floats, or characters. Once an array is declared, the type of data it can hold is fixed. You aren't able to mix integers and strings, for example. Each individual value in the array is assigned an index. In most languages, the first element in the array is indexed as 0. So, if you have an array of 5 elements, they would be indexed from 0 to 4. Let's discuss this further. Pay close attention, because this is a stumbling block for many new programmers, even the best of them. Remember this like a mantra. Arrays start at 0, not 1. 0, nada, nothing. Got it? Great. Take a look at this innocent little array. Grocery list. If I ask you, what What is that, grocery list 1? What would you say? Here's the array for you to ponder. No, it's not milk. Remember the mantra. Milk is lounging at index 0, so at index 1, we have egg. Good. So, if our grocery list array has 3 items, what do we find at grocery list 3? Oh, don't tell me you fell for that. It was a trick question, Explorer. There's nothing there. If you were to venture so far out to index 3, you'd be rudely met with an out-of-bounds exception, a digital slap on the wrist for trying to access memory you were not given access to. So, tread lightly and count carefully with arrays.
Yeah, it's fine.
All right, Explorer. If you've gotten your head around a one-dimensional array, let's kick it up a notch. Get ready for the two-dimensional array. Sounds stupefying, doesn't it? Think of a one-dimensional array as a straight line, a single row of elements. Now take that line and add more lines below it like a grid. Voila! You have a two-dimensional array. Think of a matrix, such as a chess or checkerboard. So if you had a 2D array like this, you could access egg from Monday's list with weekly grocery list 01. Remember our mantra, arrays start at 0. Be mindful not to lose yourself in the matrix. It's all too easy to get an out-of-bounds exception if you're not careful. Stay vigilant. Now, let's take a step back and try writing up our key map. For example, in the context of our 4x4 keypad, we could have an array that looks like this. This two-dimensional array has 4 rows and 4 columns to represent the layout of our keypad. Look similar to anything? Here's a photo of a different 4x4 keypad with equivalent functionality as ours from a small company's Adventure Kit 2 from around the same era as our hero board was produced. Well, we're not just going to stare at our spanking new 4x4 keypad, are we? We want to see it in action. But how do we read the button presses, you ask? Time to bring out the heavy artillery, our keypad library. It's got a nifty function tucked away in its folds called GetKey. GetKey does exactly what it sounds like. It fetches the key that's been pressed. Quite ingenious, really. What do you say we cut to some instructional material that I was able to gather? Cache on the computer. I've also added this to your mission resources for future reference. You're welcome, as always.
Hello and welcome.
Hello, yes, this is the part where I take over, haha. Hee hee. Yeah, arrays. Oh god. Array functions. I hope y'all are gonna stay with me on this one. They're not that bad, but they are a little difficult to understand if you've never thought of the concept of starting at 0. I do like that she pokes a little fun at that. When you're counting to 3 and you're working with arrays, it's 0 through 2. Because you start at 0. Now, understand me on something here. If you truly wanted your array object to start at 1 and not 0, I've seen programmers do this. I don't do this, but I've seen people do this, where they just don't put anything into position 0 and make the array 1 unit longer than they need it to be. So for our 4x4 keypad, it would be an array of 5x5 instead of 4x4, which would mean 0 through 4, and then just don't put anything in the zeros. We're not going to do that. We're going to do it correctly. But I've seen some pretty funky code when it comes to just not being quite used correctly. It's not bad. Once you've worked with arrays a little bit, it doesn't hurt too bad. It hurts a little bit, but nor here nor there. Alrighty, we're going to sift through the comments to see what they've given us here, and then start clicking some buttons. So, it says, today we are working with our 16 buttons with rows and columns. Now, probably one of the most important things to note is that rows and columns, what's the difference? Well, the easiest way to remember what's a row and what's a column is remember this. Columns hold things up. If the roof of your house needed to be held up with something, you're not going to hold it up with a row, because the rows go left and right. Columns, on the other hand, go up and down. Columns hold things up. The same idea with an array is the same kind of thought process in the program known as Excel. Excel has rows and columns. Whether you're programming with the Hero board, or you're working with Excel in the Microsoft suite. Columns hold things up, and rows run from left to right. Easiest way to remember that. Because if you look at the columns that hold up the super fancy roofs of the really old buildings in Rome, that's what's holding them up. She didn't really stress too hard on that, but if you're trying to understand the concept of an array, you need to get that through your head of what the difference is between a row and a column, otherwise that you're just going to add confusion to this. Oh, one additional thing before I dive into that code, the new code for us to play with here. Before we do anything in here, something very important, we need to add some notes. I paused mid interaction there to install a library. So before we do anything to add code to this, we need to add some notes that I did something additional to this project before I compile it. Reason be, if I rewrote this day 11 and don't include the library and I have no notes in here to remind me of that, I'm not going to do it. It's not going to work. It's not going to compile. And I would have to figure out through the errors as to why I'm calling on something that's not installed. So to skip the part of screwing myself in the future, I'm going to add comments right now to it. There we go. Okay. So before I look into anything else, I need that to be at the top of the project, because it's a prerequisite that's required to make anything that's written below to function. Anytime you have code that relies on something else, whether that's external code in another file, or in this case, a library that's required to be present and manually installed into the project, add notes. You're going to save yourself a world of trouble when future you comes back and will thank past you that you actually left yourself some notes. Otherwise, it's not fun. You have to figure it all out again, which is okay if you're learning, but why kick yourself in the face if you don't need to? Alrighty, let's see here. Arduino concepts. Okay, so like any other project, we need to include the Arduino to this, like every other project, because this is the stuff that interacts with the physical interfaces on our board. If I don't include it, we're going to have a bad time. So, like any other project, we include the Arduino suite, and that gets us off to the races. Alright, let's see here. It says, instead of writing all the code necessary to check all 8 pins and calculate which buttons is pressed, we use the library that already has been written for us to simply call the function within the library. Please refer to the lesson and lesson videos to load the keypad library to your IDE, which we've already done. Now, just like the library for the Arduino that is manually required to be included, we have to do the same thing for the keypad library. Now, the Arduino library is included in the compiler, the Arduino compiler by default. We didn't have to add it. It was already present by installing what is there. So by now including our now installed library, well, we can now make it do something for us, because we've included it, but we've also installed it. You can't call it if it's not installed, which is why I have this comment I added up here in the top. If this is not installed, calling it and functions that are built into it won't return anything. You'll get errors. That's why. Oh, my apologies, King. I jump back and forth when I'm doing this part, because I'm copying the code out and explaining as I go along. Okay, so our keypad has 4 rows and 4 columns. So there's 4 columns that hold stuff up, right? It goes up and down, and then 4 rows that go left and right, right? So that is real easy. So we know how many of each we have here. those get declared above the setup to indicate they're just a constant number, right? And it's stored in a byte, which is a byte can hold up to 255 values, and we're storing just the number 4. So 4 by 4. You technically could use the same variable for both the rows and columns, but that would be confusing. So instead of doing that to ourselves, we have separate variables for each. Okay, this is where we're going to dig into some of the array stuff. A one-dimensional array is like a list of similar variables. We use an index number to access each individual item within the array. To access the values, we use the array number, right? And indicate the constant of the position of the value we're pulling out. I'm going to explain this in different terms, but I'm just running through what's written here. So, as it stands, these constants are above. Yeah, these are all above the setup. Okay, just wanted to double check that. Okay, so being that this is declared as a constant, these particular positions, or we're referring to them as positions, are constant. These numbers will not change inside of this array of our positions inside of the columns and rows. Alright, so that's our one-dimensional array, which is pretty straightforward. Two dimensionals, I'm going to be honest with you, I don't use two dimensionals really near ever. So this is going to be a bit of a learning experience for myself as well, which is fine. Let's see here. So it says a two-dimensional array combines multiple rows of one-dimensional arrays in a table using two indexes using square brackets. Hi Xenor, welcome in, lass. Yes, we are working with code, and right now we're very painfully looking at the concept of 1 and 2 dimensional arrays to make some buttons work. It makes sense once we get to the point, but yeah, it says access any item in the array from the first index is added to the row, second index is added to the column. Yeah, buttons, you better believe it. Now here's the crazy thing, which I'm kind of grateful they didn't do to us. You can have arrays of multiple dimensions of more than just 2. We have a 2-dimensional array which has 2 positional parameters. You can have as many as you want. You can have like a 16-dimensional array. I wish you luck if you ever do that to yourself on purpose. I would never want to do that to myself because that sounds fairly painful. This chunk of code, whoops. These are, again, constants, which means the values inside of this array will not change. Dot matrix, you better believe it. If we had physical labels on our buttons, which we do not have, we have just black push buttons. They're momentary switches. This is the meaning we're giving those buttons. So first position, first column, first row is the number 1, right? First row, last column is the letter A. If we had our buttons inside of an enclosure, we would actually have these labels on the buttons so that we could visually see what those things mean. But that's why it's a constant and the buttons are stored in a char variable type, because a char can be either a number or a letter. But the thing that's important to note is that a char is an individual value, which means that I can't add an additional number or an additional letter mixed in here because a char is an individual character. You can change the internal array, you can't change the dimensions. Oh, I have that back. I have that incorrect then. Thank you for the clarification, Xenor. Like I had mentioned earlier, normally when you define constants, usually the values inside don't change, but it looks like that's not the case with this. Well, I know that when the structure is defined, oh yeah, that's right, you are a programmer. See, this is why we have helpful beings. Thank you, Xenor. Like I had mentioned earlier before you popped in here, if I make a mistake or I don't understand something and I'm trying to present something, by all means, please say something. Because I'm going off a combination of what I know and the presented material that is before me, and I'm not going to get it right every time. This is one of those times. I appreciate your input. It's greatly appreciated. Okay, we've got that in here, and then let's see here. So using the keypad library, which we've already imported, we're going to define a custom keypad to return the character we wish when we click the key physically in the physical world. To do this, we will create a hero keypad object configured with our button array, the pins used for the rows and columns, and lastly, how many rows and how many columns are on the keypad. This also does the proper pin mode commands, so we don't need to declare them in our setup. That's fantastic. So this is actually mapping for us what our keys are doing because we're calling on the class. I don't need to minimize that one. I keep minimizing that one. Right, so hero keypad is equal to keypad, make key map of the buttons, and we gave it the row pins, the column pins, rows and columns. So if I scroll, actually I don't have to scroll up, it's all right here. So we are mapping our buttons by their physical position, and then our actual dimension. In this case, it's a 4x4 keypad. So it's going to make a 4x4 grid of all inputs automatically because of this make key map function that's built into the class. Otherwise, I would have to manually define all 16 buttons by hand. But that's why you use a library, so that you don't have to manually do all that code. Multiple 16 lines of code is condensed into one. Your stacks and heaps. Ugh. Telling you, melting brains over here. Okay, my favorite part, where we start the serial monitor. This has to be done once in our void setup, so that we will see something down here in the serial monitor that's behind my head. I'm going to save my progress thus far, and then we're going to swing back over to here, and then we are then going to grab the stuff here that is going to go into our loop. I always recommend, if you know what the function does, to try to make it yourself. Just functionality. I mean, that's fair if the function itself isn't too overly complicated. I could see doing that. I am a terrible individual of reusing code, so you'll likely see me copying and pasting stuff because I'm a mad lad. Alright, I don't need this here. This was just the general concept. No, that's completely fair. I mean, I do write my own functions, which is nice because if you reuse an existing black box and it doesn't have the thing you need, then it's very difficult to convince it to do something different if you didn't write it in the first place. So I get that. That's fine. In the case of this is just a time saver. Let's see here. Alright, so it says the... Wait a minute, that's commented out. Why is that commented out? Hero keypad dot wait for keys. Hang on, I gotta go back to the example. Why is that commented? Wait for keys. We'll wait here until a button is pressed. Return the character we defined in our buttons array. Which, right, because we functionality gave a meaning to the button. Pressed buttons. Oh, it's down. I'm stupid. It's down here. That's just a comment indicating why. I was looking for that to be at the beginning of a line, not halfway through. Okay, I'm silly. That's fine. Right, so we know that we're working with chars. So the variable that's going to capture our button press is also going to be a char, because that's exactly what it's going to return. And there's nothing else it could do other than that. My buttons, smash hammer. Hey, don't you break my buttons. I need my buttons. I just spent the time wiring them. Which wasn't a lot of effort because they're push-on connectors, but still. I appreciate you being here, Han. Let's see here. So we are capturing our button press from the hero keypad class that we did, or excuse me, a library that we included up here. Oh, the bugs. Oh, you missed it from earlier. I created myself quite the disaster. It was fun. Bugs everywhere. They come crawling out of the walls. Now this is a wait for key press function, so wait until a button is pressed. So I would expect once I compile this that we will see nothing in the serial monitor until I actually click something on the keypad. And then once it's been captured, the loop, then after it's done waiting, then down here is it actually prints to the serial monitor what I clicked. But this variable that we're storing is based on a wait for function. So I expect to see nothing until I click things in the monitor. So let me compile it. Make sure I didn't add or remove something I should have needed. Okay, done compiling, which means I don't have any syntax errors. I am now going to move this over here so it's not behind my head. I'm gonna upload it. Okay. Now, as expected, like I thought, we have nothing in the serial monitor. But I also haven't clicked any buttons yet, so there's nothing there. I am going to show this from both angles. I am going to click a button. You're going to see it here in the console, and I'll show you where I'm clicking. If I understand the grid correctly, the top of the board should be where the wires were connected, which means my position 1 on the keypad should be my upper left when I hold it. The way that I'm going to. USB kit. I'm gonna have a bad time. It should be fine. Oh, I'm silly. Okay, hang on. Before I click buttons, in infinite wisdom, this is actually kind of convenient. I'm gonna show you something I didn't notice earlier here.
I made my general assumption it was incorrect. There are numbers and the letters of the grid of each switch, its position in the array, printed on the board. If I had looked at this earlier, I would have known that, but that's okay. Which means that position 1 is actually this button right here. It's not in focus, it's not going to. My camera's very sad. It's a cheap webcam, but it's printed on here, so it has S1 through S16, indicating the physical position of each of these buttons. So that means that 1 is right here, and the wires then sit to the left. So when I click S1, we are going to get 1 in the serial terminal. And lo and behold, well, there it is. And then I'm gonna click 2 and 3 and 4. Now position 4, as we looked at the grid, was the letter A, not the number 4. Button 5 is 4.
and then so on and so forth. I get 5 and 6, and then letter B, right, as I'm going across. Now I'm going to switch back just to show you what way I'm clicking the buttons.
So I then have, I went through these top rows, this top row, from left to right. So I got 1, 2, 3, letter A, 4, 5, 6, letter B. And then I'm going to go through these and then switch source to show you again. So then we've got 7, 8, 9, letter C.
Which if you take a look here on the monitor, there it is. So 7, 8, 9, letter C. And then finally, the last row of the madness is numbers. Oh, that's right, it was a star. Star, excuse me, 0, the pound symbol, and the letter D. Now, that arrangement comes up like that because if we take a look at our code, we can see here that it was just like I had clicked it. 1, 2, 3, letter A, which was row 0, right? And you can see that 1, 2, 3, letter A. Oh, that's behind my head. You get the idea. And as I clicked through each row, in that bottom row, there's the star, 0, pound, and then the letter D. But I can't spell my name. I would have to include the alphabet in there, which I actually can remap the keyboard to spell my name. I will edit the code. I like your idea. Let's do that. We've got all right, hang on a minute. This is gonna greatly bother me, so I am going to open up Excel here, and I'm going to alphabetize my name. Just a moment. I'm gonna do A to Z. Alright, I'm gonna make this really hurt me. Right, because it's a char, it can't be double letters. Right. So, if I just make this as painless as possible, which it's probably gonna be painful anyway, I'm just gonna do it so that I could just go row by row. So I'm gonna do 1, 4. Actually, technically, let's do it the other way. Let's just do it so I can just click it in order. Otherwise, it's gonna make my brain hurt. Okay, so I'm gonna do that. I'm gonna verify it. I think the dash is okay. That should be a legal character. It is. Okay, good. So then now, there's one more thing I want to do. Alright, fine. I can do that. But there's one more thing I want to do. I want to remove the space so that it prints straight across. And then that's print line. So I believe to get it to print without the carriage return, I just have to remove the LN for a new line. So if I do that, comment that out for a rainy day, compile it, and then I'm gonna move it up like a show. Windows 11, could you not please? I'm gonna clear the terminal. Nah. Okay. That's probably gonna mess up the VOD, but oh well. Turn it off and on again. Oh god. Yes, everyone. Sorry about that. We had a bump. That just dropped a bunch of you on your head. Yep, I had to do the same thing on my mobile as well. Bummer. I lost a lot of the audience. Sorry, folks. I stopped and restarted the broadcast because I don't know what happened. I didn't lose my internet connection, but all of you just kind of promptly disappeared. Wait, what? What's going on with my... Oh, my closed hang on, I gotta restart closed captioner. Oh yeah, that's real messed up. Hang on a moment. Yeah, Twitch is real upset. I wonder if they just had a blip in service there. Oh yeah, my closed captioner stopped. Closed captioner, closed captioner. Closed captioner, test 1, 2, 3. What? Hang on, I gotta restart closed captioner, reload. Click to start. Testing 1, 2. That's better. Closed captioner is back online. I think that's salty. I don't know what happened there, but that's okay. We are going to pick up where we left off here because we're actually almost finished. Yeah. Okay. Cool. Well, that was annoying. No, the upload to the Uno is on a separate computer. You guys are watching this through a capture card. I could reboot the computer you guys are watching right now and nothing would happen to the rest of me. Separate system. I don't know. I don't know what that's about. Because that's a direct USB connection to the Uno. Yes, hold off on that for a moment until we get through this part, and then yes, I want to see what your thoughts are. Only because I haven't had dinner yet, and I was planning on doing that afterwards, but stream ran a little long, and I'm getting hungry. So that's okay though. We've been learning. This has been an incredibly educational evening. No here nor there. Okay. Yes, I am going to lose tracking. Apparently. Can I have my face? Thank you. All right, let me get in front of the keypad there. Oh boy, it's a challenge. A challenge for the research. Oh, chat, I'm in danger. All right, I'm not gonna switch back and forth, but if I did this right, we should be able to spell out my name. I need to send the code to the hero board. And I crashed again. What do you mean I crashed again? I should not have crashed again. Uploading done. Alright, maybe I just didn't upload. Was that the mistake I made? Yep, it was. Okay, that's okay. No, that's fine. I just didn't upload the code. So I'm just gonna clear the terminal there. And okay, no, I didn't crash. My phone scared me. Okay, so with this being the way that it is, I'm gonna do TECK HEAD 41, and then we're gonna do a space, and then we're gonna do boop, boop, boop. All right, I like that. That's fun. I appreciate that thought. That was a good one. I like that. Oh goodness, an electronics store, you say? I can promise nothing, because that kind of stuff has been very difficult to get my hands on as of late. But please share your thoughts with me. I'm curious as to what you've cooked up. I am not necessarily a programmer, but I am having fun with what we are been up to lately. I say that, but I can still kind of program. I don't know. I see stuff in things. I am curious. But this is okay. A shift registers make this, but use a mix of 4 wires to the Uno. Interesting. I'm currently using what, 8? Let me look at the diagram. I'm using 8 right now, aren't I? 2, 3, 4, 5, 6. Yeah, I'm using 8 wires. A shift register to make it, but use a matrix of 4 wires to the Uno. Huh. It's definitely a challenge. I don't know if I'll be able to do that, but I am interested in it. Huh. Alright. Fair. Give me one moment. I'm gonna screenshot that so I have that for later. Boop. Alright, so I got that. Excellent. Yeah, no, that's appreciated, you know, I would like that. Timing I'd have to work out, but yeah. Okay. It sounds like the shift registers then actually connect to the rest of the pins on the keypad, and then there's only 4 wires from the shift register that hooks up to the hero board. And then through the logic of programming, you get access to everything else. Yeah, no, I'll look it up off stream of what they do, but that's kind of what it sounds like it does. Fair point. Huh. Yeah, absolutely. Alright, cool. With that, we are going to call it here, folks. So I'm going to give us our little raid message, because I know where we're going, and she's still live. So I mean, I'm assuming my phone isn't lying to me. Yeah, please do. That would actually be preferable. Let me see here. I'm gonna add some emotes to this. Okay, so this is gonna be the raid message. If I can click in my own box, please. Be super cool if this menu could be out of my way. We are going to be raiding into an individual that I met at Nipple's wedding. She's very nice. Padra is her name. I've put her in a couple of our advertisement boards because she does some fun stuff. Haha. All right, good. I am kind of semi good at what I'm doing here. But looks like that she's currently doing the game Vintage Story that looks an awful lot like Minecraft, to be honest with you. I was watching her play it the other day, and it's it's cool. It's cool looking. So we're going to be doing more silliness in the times to come here. Yeah, thank you for your input, both you, Panic, and Xenor. I very much appreciate it, because this is very much a learning experience. It is for me, as it is for those of you who are watching. So I very much greatly appreciate your input on this madness. Yeah. Good. Yeah, thank you, Pyrex. I appreciate that. For now, I'm gonna go grab some dinner. All y'all, enjoy. Madness is a yes, madness I say. Bye-bye.